don't forget. Okay.
There would be a review for the final exam as well.
Mm-hmm.
Okay.
There will be. Yes. I'll be doing it probably on Monday. And so y'all can, or maybe on Tuesday, even though the last day of class is Monday. So I probably should do the review then.
Okay.
And then all we'll have to worry about is the final exam.
Okay.
Okay, let me see. Okay. Hey, Araceli. Okay, so let me get started. This is the review for test 4 over now. It's also sections 4.1 because we didn't get to 4.1 last time, I don't believe, on our test. So it's going to be all of these sections. 4.8 and 6.1 will be on the final, but not on this test. That'll help you out a little bit, I think. You don't have quite as much on this test. So the things that are on this test, well, one of the first things is, let me see, where did I have that? Hold on just a second. Yeah, the composite function. And I'll do some examples of that too, but in 4.1, we had the composite function. And so remember, for the composite function, that you've got two functions. Well, it could be a composite of a function with itself. But say you have two functions, f and g, find the composite function and state the domain of each. So let me just do this example. So the fog is the f of g of x. I like that notation. So really, it's like you're putting the g of x, which is -7 over x, into f. It's like you're actually taking this and putting it wherever x is. And see, there's two x's in f. So you have to put it in both places. So what that gives us is we have a -7 over x in the numerator, and we have a -7 over x minus 2 in the denominator. Now, this is what's called a complex fraction. And we run into these a lot in math. So if you're going to go on and take calculus, you'll run into these again. But there's more than one way to simplify it. One way is to just get a common denominator down here and have one term in the denominator. And then you can actually change it to multiplication by the reciprocal of this. Another way, which is, I think, the easier way, is just to multiply the numerator and the denominator by the same number. And if you multiply by the LCD, which is x, so I'm going to multiply by the LCD. So I'm going to multiply by x in the numerator, and I'm going to multiply by x in the denominator. And see, really, it's like we're multiplying by x over 1. And you know, if you multiply in the numerator, if you multiply by the same thing in the numerator as the denominator, as long as you're not multiplying by 0, it's really like you're just multiplying by 1. And so it doesn't change the expression. So what will happen is this will cancel. So in the numerator, we're just going to get a -7. And over here, what's going to happen, and I'll just distribute, you've got a -7x over x minus a 2x. And so this x cancels. So we have a -7 over a -7 minus 2x. And I hope that's right. Any questions about that?
No.
No, you already know how to do that. Okay, that's good. Then let me see. And then it also asks for the domain. So the domain of a composite is not just the domain of this answer right here. and this is a little bit complicated, the domain of f of g of x. Well, see, x has to come in to g of x. That's where x comes in. So x must be in the domain of the inside function. Now, g of x isn't always the inside function. If we were doing this one right here, that's g of f of x, and the inside function would be f. So whatever's the inside function is either the last thing written here, or if it's written like this, it's the thing in the inside, which is why I like this notation better, because it shows the inside function inside. So anyways, x must be in the domain of the inside function. And in the domain that's right, because it's like I'm writing lopsided, of the resulting composite. And that's, in this case, the f of g of x. So you see, the inside function g of x was equal to, negative 7 over x. So the domain of this function is x can't be equal to 0. Then the resulting composite, we got this function. Okay. So we got this function, the negative 7 over minus 7 minus 2x. So minus 7 minus 2x can't be equal to 0. So minus 2x can't be equal to 7. So x can't be equal to a minus 7/2. Now, if you were to write the domain out in interval notation, because we've got to skip over 2 numbers, it's kind of long and drawn out to write it out in interval notation. But we'd have from negative infinity up to negative 7/2, because that's the first number we're going to skip over, union with from negative 7/2 to 0, and then we're also going to skip over 0. That would be what we would write out in interval notation. So, there'll be a problem like that for the composite. Now, another thing that could be on there for the composite is a problem like this. Although, there could be a multiple choice problem like this. And remember, guys, that your test is going to be on iCollege using a lockdown browser, and you'll be recorded and everything, the Respondus monitor and all that. But there could be a multiple choice question. And probably most of these questions are going to be multiple choice, because if I do free response, it's hard to make the iCollege accept all kinds of different ways a student might enter it. But find 2 functions, f and g, so that f of g equals h, where h of x is this 9x plus 9. So I think the most obvious answer would be that f of x equals x to the 7th, and g of x equals 9x plus 9. Now, that's not the only answer. These problems usually have more than one correct answer. But if you did use this, f of g of x would be equal to, well, you put the 9x plus 9 inside where x is. So you could have a problem like that. Question about that, anybody? No, about anything? Okay. I don't know if I'm going to work all the problems out, because these are from the document that's on iCollege, the review that I did last semester in class. So let me see. Back to my review. So then in section 4.2, we need to be able to find the inverse of a function, use the horizontal line test to determine if the function is 1-to-1 or not. So, you know, that would mean not 1-to-1 because a horizontal line touches the graph in more than one place. Use the definition of inverse functions to determine if two functions are inverses. And what that means is that if you do the composite of a function with its inverse, you would get back x. And that's because if they're inverses, they undo each other. So x goes in, x comes out, and nothing is done to x because they undo each other. It's like if you multiplied a number by 2 and then you divided it by 2, well, you're going to get back that number. Thus, multiplying by 2 and dividing by 2 are inverse operations. But we're talking now about inverse functions, but the same thing is true. So you can tell if they're inverses by just doing the composite. And generally, I mean, it's possible that if it worked one way, it wouldn't work the other way, but it would be kind of a weird function for that to happen. So find the inverse of a function. Find the domain and range of the function and its inverse. So we'll need to know the steps. And we'll look at that in a second, but there's steps for finding the inverse of a function. Graph a function and its inverse. So remember that a function and its inverse, there's some symmetry. This is a line y equal x, and there's some metric about this line. So for instance, if this has a point on it called, or let's do this one. Let's see. Let's do that point and that point. So let's say that this has the point, well, it's going to be 0 and some y value. Then this is going to have the point, some x value and 0. So basically their x and y's are interchanged. And also their domain and ranges are interchanged. So this is just another example of how they're reflected across the line y equal x. Let's just do a y right there. So graph the inverse of a function given the graph of the function. That would be like if I gave you this and you had to graph this. Now, so remember, the domain of f is the range of f inverse, and the range of f is the domain of f inverse. So let me just look at some problems where I did some problems with the inverse. I may not work them all out because I know y'all don't want to sit here forever. Huh. Where are they? The big sum on here. I don't see them. Well, let's just go on and then I'll try to find out what I did with 4.2. Exponential functions, like for instance, y equal 2 to the x. It will have a horizontal asymptote. And normally it's going to be y equals 0. If it was this function, it would just be y equals 0. But, you know, if it's y equal like 2 to the x plus 5, where the 5 is down here added to the 2 to the x, the horizontal asymptote would be y equal 5. So anyways, they do have a horizontal asymptote. It's going to go through the point 0, 1. Because if x is 0, 2 to the 0 is 1. Anything to the 0 is 1. Graph exponential functions. So they're going to look like this. They're going to have a horizontal asymptote. Solve certain types of exponential equations. So in other words, if the bases are equal, now there's only, you know, this is not always, it's not really usually the case where you can rewrite the other side of the equation with the same base. But if you can, then you can do this. Like for instance, 9 is 3 squared. So we could replace the 9 with 3 squared. And then when you raise an exponent to an exponent, you multiply. And then once we have the same base, we can set the exponents equal to each other. And then we can just solve for x. And, you know, we'll have some kind of equation to solve. Could be that it's quadratic, or it could be that it's linear. Now, we learned another way to solve exponential equations in, I think it's chapter 5.6. And that's where we take the natural log of both sides. You could do that here and you would get the same answer or an equivalent answer. We'll look at that in a minute. Then the log function has a vertical asymptote. And normally, so what the log function looks like, let me just graph one so that you can see it. Let's just do the natural log. It looks like this. And so its vertical asymptote is going to be x equals 0. Now, you know, let me show y'all something. I think I showed it to you in one of the videos, but if you want to graph a log other than base 10, you know, this button right here where it says log is base 10, and this is base E, the natural log. But if you want a different base, you can go to math, I believe, and let's see, let me check. Is it just down here? Yeah, log base. And it'll let you enter the base. So let's say we're going to do log base 2. And this is on the newer calculators. On the older calculators, you'd have to use a change of base formula, which is covered in one of the videos as well. But that's log base 2. So they have a vertical asymptote of x equals 0, unless it's some kind of, you know, unless it's shifted left or right. If it's shifted left or right, it's going to shift the vertical asymptote. Now, be able to convert between exponential form and log form, and this is really the key right here. Remember that log base b of x equals y is equivalent to b to the y equal x. These are equivalent, and if you don't know anything else, be sure you know this, and I hope you know everything. But when we're trying to evaluate logs, we use this rewriting it. So we're thinking b to what power gives me b to the x. So for instance, say that we're trying to evaluate log base 2 of 4. Well, we're trying to think 2 to what power, or we're actually trying to figure out what this is. So we're trying to figure out 2 to what power gives me 4. And so what 2 to what power gives me 4? Well, it's 2, isn't it? 2 to the second power gives me 4. So see, when you rewrite it, this number to this power should give me this. So like, let's do a different one. Let's do log base 2 of 8, so we don't have the same number repeated. 2 to what power gives me 8? That's what we're really asking here. And so that's going to be a 3, isn't it? Because 2 cubed is equal to 8. Now, if we did something, and y'all stop me if I'm talking too much, but if we did say log base 2 of 1/4 equals what? So we would want to know 2 to what power gives me 1/4. Well, you know, 1/4 is 2 to the -2. So the answer would be -2. So anyway, so much about evaluating logs, and I did a video on that. Apply the basic properties of logs. So, you know, there's the, for one thing, when we're talking about basic properties, there's the log base b of x times y equals log base b of x plus log base b of y. You know that. Log base b of x over y equals log base b of x minus log base b of y. And log base b of x to some power, you can bring the power down. So these are really important. You're going to need those for a number of things. And this is called the product rule, and this is called the quotient rule, and this is called the power rule. But there are other properties of logs that we covered, and we'll look at that in a minute. Graph log functions and find the domain and range. So that's where, you know, I just showed you how you can graph this on your calculator. So you're going to need to remember how to do that again. So if you go to your y equal and you want to graph some log, you go to math and then you scroll down. Just say it one more time. And then it lets you enter the base, say it's 3, and then you enter whatever here, and it'll graph the log. Okay, so you'll need to graph the log, find the domain and range, graph a log function in their inverses, where their inverses are exponential functions. So like, for instance, the natural log and e to the x are inverse functions of each other. So if this is f of x, this is f inverse of x. And so whatever the base is here, log base b of x equal y and y equal b to the x are inverses of each other. And remember, the log domain generally, x can't be 0. You can't take the log of 0 or of a negative number. So it's from 0 to infinity. Okay.
No question.
Uh-huh.
How do you
Yes. Is that Mia? I can't hear you, Mia. Who's asking the question? And I can't hear.
I'll just do it. I'll say, how do you graph logarithms again?
How do you graph a log function?
Yeah.
Okay. So now, do you have one of the calculators? Because some of the old calculators, this won't work. But when you go to your y equals screen, and then you go to your math button, and then you scroll down. Do you see a thing like that?
Yes.
Then you just hit that and you enter the base, whatever it is. So, it can be any positive number. So it could be 5. And then you put the X in here. And then you hit graph. So if it's base E, the natural log is log base E. And this log here is log base 10. And if you'll notice above natural log is e to the x, is they're inverse functions of each other. And above log is 10 to the x because they're inverse functions of each other. Was that all the questions that you had?
Yes.
Okay.
One more thing, does that mean we're allowed to use calculators on math test 4?
You could have used it on all of your tests.
Oh, okay.
Sorry. Yeah. Yes, you can always use it, for graphing and everything.
Oh, okay.
As long as it's not a TI-89.
Okay.
TI-89s are like having access to a computer. They'll just compute things for you. But this is the calculator that you should have for the class. And 84, 83 is okay.
Okay.
The TI-84.
Yeah. TI-84, TI-83. Yeah. I'm sorry if you didn't know that.
A similar question is I see like conflicting information about like blank paper, and I know it's like a math test. So for the respond to lockdown browser, it says like, don't have any papers beside you. And I thought that I could have like blank paper with me. So I but then I was like, I don't know. So I
You
flung
can have scratch paper, but what you need, you should have scratch paper. But what you should do is just hold it up to the camera and show both sides are blank.
Yes.
Yeah. But no, you can have scratch paper. You can have your calculator. You can't use your cell phone, or go to another website.
I don't do that. So
I'm sure you don't. And you can't, have
for
stuff written on your scratch paper.
for our quiz that was on iCollege, I did blank scratch paper, but I didn't show it to the camera.
Oh, that's okay.
Okay.
Yeah. Thank you for telling me, because it might have flagged you, but as long as I know you weren't cheating. Any other questions about that?
I had a notebook like right next to me when I panned the camera around, but I didn't I didn't hold it up either. Like,
did you use the notebook?
Yes, to like work on problems.
Just the scratch paper.
Yeah.
Next time, pull your scratch paper out of the notebook and hold it up like I said.
Okay.
Yeah. Okay, let's see. Oh, here we go. For properties of logs, this is a list of properties of logs with the logs. Focus a little bit better. It looks kind of weird. This is just from, well, it's from some book. It may not be from your book. But this, it is really kind of hard to see. This is just what I said a minute ago, that log base A of X is equivalent to X equals A to the Y. Oh, and I should have said, hold on a minute, didn't do that right. Log base A of X equal Y is equivalent to X equals A to the Y. So see, what we're doing with the log is trying to find an exponent, trying to find the exponent that we have to raise the base to get this number. This says log base A of 1 is 0 because to like take 2, and the base is not going to be 1 either. It's going to be greater than 1. Oh, no, it's not. It could be less than 1. It just can't be 1 because 1 to any power is just 1. But if it's log base A of 1, then that's going to be 0 because A to the 0 equal 1. And this is just log base A of A equals 1. So if you've got like the same base as the argument of the log, that's just going to be 1. Because you know, what power do I raise 2 to get 2? That's 1. This is the product property that I was telling you about. You can bring the power property, you can bring the power down. Now, if you take the base of a log and you raise it to log base of A, base A of some number, then you're going to just get that number. These two like cancel each other out because this is the exponential function and this is a log function. They're inverse functions. So whatever comes in is what goes out. Another way to think of it, although most of my students don't understand me when I say this, what you're asking here is what power do I raise A to get M? Well, whatever this means the power that I raise A to get M. I'm raising A to that power so I get M. And then same thing over here, A to the X. Oh, this is not the same thing. Let me see, what is that? I never wrote that down wrong. That was not sure what this one's talking about. And I may be having a senior moment here. Unless I'm tired, but we talked about this one. This is the product where you can expand it, and the quotients right here. This is the change of base. So if your calculator didn't have that log base key, you'd have to do a change of base. And this is the formula to do that. So I remember it by whatever the base is, goes, wait a minute. This is what I should have done. So we're changing it. We're changing the base from A to B. So the base log base B. So we're changing to log base B. So the reason you would do this is if you didn't have a way to enter a log other than log base 10 or the natural log, what this formula would let you do is change, say, from base 3 to base 10. So you could just put 10 here. And then M goes in the top and A goes in the bottom and the base goes in the bottom. So that's the base. It goes in the bottom. I remember it that way. And this is true that if you've got log base A of M equals log base A of N, then M must be equal to N. Okay, so those are the properties. Now, I'm not going to redo everything here. But some things I could ask you to do would be like combine into a single log. So, you know, the way you would do that, it would be log base 2 of 16. Because you would multiply the 8 times 2. And then I might ask you to expand. So it's given like this, and then you expand it. So that means break it apart into log base 3 of 5 plus log base 3 of x. Or if it was like log base 2 of, say, 5 over x, you would go log base 2 of 5 minus log base 2 of x. And then if you have one with the exponents should come out front. So let's just do this too. Let's say that we've got log let's say we've got 2 log base 3 of x plus a log base 3 of something. So before we put these together, and so we're supposed to combine into a single log, you need to make this exponent go back up. So that would be log base 3 of x squared plus log base 3 of 5, and then you can put them together. Log base 3 of 5x squared. So logarithmic and exponential equations, solve log equations and check for the solution. So remember that you can get extraneous solutions with a log equation. So it's one of those, you know, you have to remember the steps for solving equations, and you have to remember which ones have special checks, like back when we square both sides in a problem, we have to check for extraneous solutions. When we're solving a log equation, we have to check for extraneous solutions. So like if you have to solve an exponential equation and you can't rewrite each side with the same base, and even if you can still do it this way. Take the natural log of both sides. And why? Why do you think that we want to do that? Because this is why. What we're trying to solve for is in the exponent. But if we have logs, we can bring the exponent down. But we can only do that if we have exponents. And so here I continued solving it. Once I take the log of both sides, I can bring x, oh, I'm sorry. I can't erase this because it's from a copy, but x should be there. The x comes down in front. And then what is natural log of e? Well, natural log is just log base e of e. Or natural log of e is just log base e of e. Because natural log is just log base e. So what's log base e of e?
1.
1, yes. Okay, and then 4.8 will be on the final exam. It's growth and decay models, solve growth and decay problems. I guess I'll just go over that when I review for the final. And let's see, let me bring that. Okay, so I think these may just be some kind of random problems that I did last semester. Work out finding the inverse. Let me make sure. Let's see, did I do one of those anywhere? Yeah, I did back here. So we've got find the inverse back here. So find the domain of this function. Well, with a log, whatever is inside the argument, this is what's called the argument. It has to be greater than 0. So you just make it greater than 0 and solve that inequality. So here we're going to have to divide by -2. So remember, we reversed the inequality symbol right here. And then we get x has to be less than 1/2. So the domain is from -infinity to 1/2 and doesn't include 1/2. And then say you want to graph what's going to happen here is you think about transformations. Let's see. Well, actually, don't think about transformations, but think about what would make this equal to 0, or just say it's got to be greater than 0. So we have -2/2 greater than -1, or x is going to be less than 1/2. So whatever this number is here is where the vertical asymptote is going to be. So it's going to, instead of having a vertical asymptote at 0, it's going to have a vertical asymptote at 1/2. So it's going to look kind of like this. Vertical asymptote. Now, if you want to graph this, I showed you how to do it with the base, but with the log button. But if you don't have that log button because you have an old calculator, this is the formula. This is the change of base formula. It's good formula to know, period. But you have to know it if your calculator doesn't have that button on it. So if you were to graph this, you would go y equal, and see, this is going to be base 10 of the argument divided by log base 10 of the base. So you would want to use either base 10 or base e, because those are the buttons that we have on our calculator. Are right here's base 10, right here's base e. If you've got that log button, you can just enter any log you want. Okay, now be able to rewrite a log in exponential form. So for instance, and in a problem like this, see, x is the base. It could be because, if this is a number, like if you're trying to figure out what log base 2 of 4 is, you could use your calculator and just enter log base 2 of 4 and you're going to get 2. But so that I know that you understand what logs are, I might make the base a variable, and then you can't do that. So you would need to understand like this, that you're going, what power do I raise the base to get 1 over x? Well, you'd have to raise x to the -1 power to get 1 over x. And here's where you really have to understand your exponents here. Or a problem like this, log base x of square root of x. Well, remember that the square root of x is the 1/2 power. And then remember that there's a property that if you're taking the log and it's the base is the same number as in the exponent, in the argument, that the answer is just going to be whatever this exponent is. But just think about it. You're really going x to the what power gives me x to the 1/2 power. So, it's obvious the answer is 1/2. So you really need to understand logs. And the key to understanding this is the log base b of x equal y is equivalent to saying b to the y equal x. You got to understand that. Stop me if you have a question. Okay, here's where we're trying to find the inverse. I'll just walk through it. If you want me to do it or do one, I'd be glad to. I'm just trying to save a little bit of time. So we want to find the inverse in so let's say that we've got f of x equals 2 over x minus 3. So that's a rational function. Well, and so the domain of this is going to be x doesn't equal 3. Now the range of it, you would have to graph it, but what's going to happen is it's a rational function. And really what this is doing is it's shifting it right 3 units. So, and the vertical asymptote is going to be at x equal 3. And that's the vertical asymptote. The horizontal asymptote doesn't change. So it's going to go like this, and then the other side's going to go like this. So anyways, it's not ever going to cross over the horizontal asymptote, and the horizontal asymptote is just y equals 0. So the range is that y isn't 0. So that's the horizontal asymptote, but it doesn't cross it. Now, the steps for finding the inverse of this function. Step 1 is change f of x to y. Okay, just rewrite it as y. Then you want to interchange x and y. And then you want to solve for y. Now, when it's a rational function like this, it's more complicated to solve for y than, say, if it was a linear function. So you're trying to solve for y. We interchanged x and y. Y is in the denominator. The way you do it is multiply both sides by the denominator, and it'll cancel here so that you get the y out of the denominator. But then over here, you've got to distribute. And then what you've got to do is, well, if you had 2 terms that had y, you'd get them both on the same side, but I only have this 1 term. So really to solve for y, I just need to divide by x. And then the last thing you want to do is call that f inverse. So this is what we got for f of x. This was f of x. 2 over x minus 3. Better. The domain of this was x doesn't equal 3. The range was y doesn't equal 0. Now, then what we got here for f inverse is 2 plus 3x over x. Now, its domain is going to be, of course, you can see, x doesn't equal 0. And its range is going to be, remember how you can tell what the horizontal asymptote is? Do y'all remember that? You can tell, but because if the degree of the numerator is the same as the degree of the denominator, then the horizontal asymptote is going to be y equal the leading coefficient in the numerator, and so that would be the 3 divided by the leading coefficient in the denominator. So my horizontal asymptote is 3, and so my range is y doesn't equal 3. Now look at how these are interchanged. The domain of f is the range of f inverse. This is the y. The range of f is the domain of f inverse. So they're interchanged, and that's always going to be true. Question about that?
No.
No? Okay. Let's see what else I got. I'll try not to keep you here all night. So solve exponential equations. And we've kind of I've already talked about this. So that's an exponential equation. Why is it an exponential equation? Because the variable is in the exponent. And to solve, you can take any log. And some people were taught to take log base 5 here, which does make sense. I was just taught because on our old calculators, when I back in the dark ages, all we had were the natural log and log base 10. We couldn't enter any other kind of log. So I was just used to taking natural log, but you could take log base anything. But you take a log so that you can bring down the exponent. That's why you do it. And you have to do it to both sides. And then I just distributed. And then I added log base 5, natural log of 5 to both sides. Then divide by natural log of 5 here. And this is my exact answer. Now, if I ask for the exact answer, this is going to be it. If it were a word problem and they asked for a approximation and they said round to 2 decimal places or something like that, round to 2 decimals or round to the nearest 100th, then you would round it. But then this is just a rule in general. Unless they tell you to round it, don't round it. Give the exact answer like that. Okay, let's see what else I got here. This is just another exponential equation. And the thing I do want to point out here is that if you've got a number like multiplied or divided by, or if your exponential expression is multiplied by a number, divided by a number, there's number added to it, you need to get rid of that first. So you want to isolate the exponential. That's really the first step. So I divide both sides by 2. You don't want to take the natural log with that 2 there. Okay, so divide by 2, then take the natural log, then bring down the exponent, and then get your answer. So these are the steps. Now, when you're trying to solve a log equation, it's totally different. You want to combine into a single log and rewrite the log in exponential form. So that means if you've got a log base b of x equal y, you're going to rewrite it into b to the y equal x. And then you have to solve for x. So for instance, here, so we want to combine into a single log. We can do that because of the product rule or property 1. We can combine a sum as long as they have the same base. So we combine into a single log. Or if you didn't have this constant here, you could get a log on each side, and then, well, you would still have to take care. And let's not talk about that right now. It's just going to confuse you. So we go x times 2x and we combine it into a single log. Then we want to convert it into exponential form. So the base is 3. 3 squared equals 2x squared. And then we've got to solve that. So this is 9. I divide it by 2. And then I need to use the square root property and go plus or minus to solve for x. But if you check this, the only solution that will work is the positive 9/2. The negative 9/2 will make you take the log of a negative number. So the negative square root of 9/2 is an extraneous solution. This is the only solution. Okay. That's just another exponential equation. You just have to distribute here. And then I'm sorry, maybe I mentioned that problem. And then it's over here. So, for instance, here's a log equation. We already have one log. So you want to rewrite it in exponential form. So natural log is just log base E. So we're going to rewrite it, and I'll write this again. Remember, log base B of x equal y is the same thing as b to the y equal x. So we go e to the 6 equals 2x. And so then we get the x equals e to the 6 over 2. And you could check it. You could put e to the 6 over 2 in there for x, and it would check. Use another log equation, and on this one, like I said, if you've got something with the log, or I was actually talking about the exponential, but it's also true with the log. Isolate the log. So what we first have to do is subtract 4 from both sides. Get rid of the 4 and then divide both sides by 8. So we need to do that first so that we just have a log on this side, and then it's just log of x equal 1/2. Well, we got to solve for x. So we rewrite it in exponential form. This is base 10. If it doesn't have any base written there, it's base 10. So 10 to the 1/2 equal x, or in other words, x equals the square root of 10. Question about that? Okay. Huh? No?
No.
This is just another finding the inverse of a function. And this is just for, in this case, the function is a radical function. So we rewrite, change f of x to y, interchange x and y, and then solve for y. And then change y to f inverse. Those are the steps. But you have to remember how to solve for y. But you know how, if you just think back to what we've learned. So I interchange the x and the y. To solve this for y, you need to cube both sides, remember? Because that will get rid, if I cube this, that'll get rid of the cube root. And then I'll have a cube on the other side, but then all I've got to do is add 8 to both sides and then call it f inverse. Remember that if these two numbers are the same, then this just undoes this, and the answer is whatever's up in the exponent. And I think we already talked about that log base x of 1 over x is just equal to -1. This is just expanding the log. Now, it may say to expand, and then when you expand like this right here, can be simplified. This can't, because 5, there is a power you raise 5 to get 7, but it's not a nice number. But to get to what do you raise 5 to get 25? That's a 2. So you should change this. If it says simplify, you should change this to a 2. But you wouldn't change this. And then this is putting the logs back together. So just like I said before, you've got to take care of those exponents first. So we want to put the 3 back, that 3 there needs to go back as an exponent. And then you can, since it's a sum with the same base, you can change it to the log of the product. And then if I multiply this together, it's 576. So that would actually that would just be your answer. I was just going back. I don't know what I'm doing there. Just so let's see. There could be a problem, like we said, where they give you a graph of F and then you've got to find the graph of F inverse. So like if you've got the point -2, 1 on F, you're going to have the point 1, -2 on F inverse. So whatever points are up here, you just interchange the X and Y, and that point's going to be on F inverse. This doesn't look very much like a, it really doesn't look very good. It should be a mirror image. Something looks really bad here. I guess it's just they should both go through 3, 3, but I don't know. I did something bad here. Well, anyway, I think I just made that look funny. And we've already talked about this. So, oh, but when I did solve this, so I'm solving. And when I put it together as a single log, and then I rewrite it in exponential form, I get this quadratic. And when I solve that, I get x equals 0 and x equals 2. But you can see that x equals 0 would cause you to take the log of 0. And you can't take the log of 0 or a negative number. So this solution is extraneous, and the only solution is 2. So watch out for that. Now, I'll talk about this, I guess, when we're getting ready for the final, because I do have a video out there about solving, or I just put it out there, solving systems of equations. So,
Will there be extra credit for the final exam?
oh no, I'm afraid not. I'm sorry, but there isn't one. It would be huge. So, but you could use the old extra credits to help you prepare. And maybe I'll put an extra credit question on the final exam. I could do that.
Oh, okay.
We already did this.
So I noticed on the syllabus that if you like don't miss any of the tests, which I have not done so far, the lowest grade will be dropped.
Well, it's not dropped, it's replaced by the final exam grade.
Yeah.
Yeah. So that's a big deal. If you do well on the final, it not only counts as the final, but if it's higher than your lowest test, it'll replace it. So if you had done pretty well on 3 tests and you maybe had one you really didn't do well on, that final will replace it. And that's a big deal. So now if the final isn't higher than any of your tests, it would not replace. But it could really pull your grade up to do well on the final. It can also really pull your grade down because it counts, what is it, 30 or 25%. And so that's a lot. So, you know, you really need to study for the final. And I mean, I look at the final too. If somebody does real well in the final and say they had an 89 point something, well, if it was greater than 89.5, I would automatically change it to a 90, but say it was an 89.1, but they really did well in the final, I'd probably give them an A. Because I look at the final as they really do know how to do something. After this class, they actually learned they learned some math. Okay. These we've already talked about. We've also already talked about this. If the base and the argument are the same, then the answer is just the exponent. I don't know why I have so many for the same thing here. trying to find something that's different. Did that. I guess I've already done everything. Yeah. So that's it, I think, really. Did we cover it? Did I do some examples of everything?
Yes, thank
Oh,
you.
I think that's it.
I've already started studying for the final.
Good for you. That's a great idea. And you know, you can go back and work on your old test that you took. You can also work on the problems that are in iCollege. You should be able to go back and work out the extra credits. Although I guess if you didn't do the extra credit, you might not be able to do that. So, I don't know. I
So
guess
you can, sorry.
Go ahead.
So you can do like the iCollege old tests and and the tests that you did recently,
Yep.
like for this semester.
Yeah, you can go back in and review those.
Yeah.
And you can rework the problems.
Mm-hmm. Yes.
Because you know, you've got to work problems. And I will do a review, and there actually is already, or I can put a review from last semester. I can go ahead and put it out there in YouTube. So if you want to go ahead and watch it, I mean, I'll do a review again. But if you're already studying for the final, you might want to go ahead and watch it. So I'll put it on YouTube. I need to remember to do that.
How many questions will be on the final exam?
Well, not more than 20, I don't think. Well, I guess it could be more than 20. You've got 2.5 hours. So I don't think there'll be more than 20.
Okay.
Yeah. And maybe less than that. Go back, I honestly don't remember how many. Oh, well, I don't have a final exam created for online. I'll have to create that. So, well, I did from a long time ago, but anyways, I probably will recreate a test. And so, yeah, I'll say not more than 20.
Okay.
More questions?
No.
Is that all?
Yes, that is.
Yes.
Okay, thank you for coming, and y'all study hard. The end is just right around the corner, and y'all are great students.
Thank you.
All right.
Yep.
Bye-bye.